All right, a question came up about part C from the Polar in class, problem number 1. So find the equation of the line tangent to the graph at the xy coordinate 1, 0. That means that we already have the point on the tangent line. All we really need to find is the slope. So in general, thinking about graphing this function, if I start when theta is 0, then I end up starting at this point right here, because if I plug it in, it would be -1 plus 0, and the radius would be, so out at 0 and then going backwards 1. In between that and pi over 2, I end up drawing this portion, right, because at pi over 2 the radius is going to be 2. Then between pi over 2 and pi, I end up drawing this portion. So that's the point that I'm really talking about. When the xy coordinate is 1, 0, then the radius is -1, and the theta value is pi. Keeps going. So I basically did a new color in between each of these different places on my table there. Okay, after that, I have to start with x is our cosine theta, y is our sine theta. I substitute in the r, and then I substitute in the r here. So for the x, it seemed easiest to me just to go ahead and use the product rule, right? Derivative of the first times the second, leave it alone, plus the first times the derivative of the second. For y, it looked easier to me to go ahead and simplify and then use the chain rule. You could use the product rule also, it really doesn't matter. So that's my dy d theta. So after that, I'm going to find the slope dy dx by doing dy d theta over dx d theta, and then I'm just going to go ahead and plug in my theta value, which was pi, to find that slope. Once I find that theta value, then I'm going to go ahead and do y minus 0 equals this slope times x minus 1, just using point slope form or something like that. So I think I did the rest on the answer key. I think the trickiest part is actually figuring out this r and theta. All right, thanks. Let me know if we need more help.